Hi, welcome back to the Azure Cloud Native series. I'm Gary Hope, a program manager on the Azure Cosmos DB team. This is the second part of our video looking at what makes Azure Cosmos DB a great database for your cloud native application development, and we will continue to look at some of the levers you can use to optimize cost when using it to build these applications. If you haven't watched the first part of this video, I suggest that you do that now, as we build on some of the concepts explained there. In the previous video, I introduced Azure Cosmos DB and provision throughput. We ended with some demos on how you can practically provision and manually adjust throughput to make sure the provision throughput matches your application requirements, either through the portal, writing an automation script, or programmatically in your code. What if you don't have such automation in place and you need to cope with regular fluctuations such as those associated with daily business hours, changes in needs over weekends, or monthly billing cycles as examples? This is where you want to automate the adjustment of your throughput for a specific time of day, or week, or month. We're going to configure some automation to manage the throughput of our dedicated container. First things first, I need to download the project from the repo. Let's open the project and see what it contains. Here you can see there are two functions, one called scale up trigger and the other scale down trigger. Within each function definition, that's the function.json file, you can see they are defined as timer-based trigger functions. And you can see they have schedule attributes that defines when the timer triggers the function itself. Those of you familiar with Unix or Linux will recognize that this is being specified in cron format. In this case, 8 a.m. every weekday. Every day at this time, the function will run the PowerShell code defined here. First thing the code does is retrieve the resources to be updated and their target values. It then validates that the database or container exists and what API it's using. It then does some checks and finally sets the throughput to the value configured in the resources JSON file. As I mentioned, each of the functions has a resources file that specifies the resource group, the account, the database, and the container you wish to manage, along with the throughput value desired, in this case 4000. Here you can see the same scale down function, specifying the throughput should be brought back down to 2500. Switching back to the portal, you can see here I've created an empty Azure Function app, as per the instructions in the repo, ready to receive the functions themselves. Back to VS Code to deploy my function by hitting F1, selecting the Azure Functions deploy, specifying the resource group, select an Azure Function app, the one I just created, and click deploy. A couple of seconds later, we're done. If we now go to our Azure Functions app, click refresh, click functions, you can now see the two functions we just created. I've opened browser tabs for each of the functions here. Let's refresh these. If I click the test button on the function, I have the option to run the function now rather than waiting for the scheduled time. But before I click test, let's check what value the throughput the dedicated container is configured for now. Here you can see the dedicated container is configured for 4000 request units per second. Going back to the scale down function, we can click run, remembering that the resource file was configured to adjust the throughput to 2500 request units per second. We give it a couple of seconds to run to completion. And now we can go back and see if the throughput has been updated. Hit refresh, and here you can see it's been scaled back down to 2500 request units per second. The same would apply to the scale up function. For now, I'll leave that up to you to explore in more detail on your own. What if my traffic patterns are unpredictable? In this situation, it's impractical or even impossible to use manual scaling because we never know when we will need more throughput and when we will need less. That's when autoscale comes into play. In this mode, you only have to configure the maximum amount of throughput you expect your application to need. Azure Cosmos DB will then automatically scale your provision throughput up and down to accommodate your application's requirement within the range that spans from the maximum level you configured down to 10% of that maximum. Autoscale delivers on the exact same availability and latency promises. It is the best solution when you have unpredictable traffic patterns, but also need to guarantee performance. Let's create a new container in the same way we did before, selecting the database we're going to create it in, giving it another imaginative name, specifying the partition key, choosing to provision dedicated throughput for this container, and here, instead of choosing manual, we're going to choose autoscale. Here I'm going to specify the maximum value up to which we want Cosmos DB to automatically provide throughput. It will automatically scale back down to 10% of that value when not needed. Clicking OK. If we go to the overview page, you can now see autoscale container with 4,000 request units per second max. Let's click back on the container itself and drill back into the settings of this container. As you can see here, we can revert back to manually provision throughput whenever we choose. Azure Cosmos DB offers a free tier that gives you the first 400 request units per second throughput and 5 gigs of storage free each month. Free tier can be applied to production apps and offers a discount that developers can take advantage of for their life of the account. This gives you an effective 400 request units per second, irrespective of whether you use standard or autoscale provision throughput. This capability is especially interesting when combined with autoscale throughput. Not only does it provide you with 400 request units per second discount, no matter how large or small the throughput is scaled to. When a container is configured at a maximum of 4,000 request units per second, the minimum 400 request units per second effectively disappear when free tier is enabled, thus providing you with a deployment that is completely free in the hours where there is no or minimal application traffic. Remember that Cosmos DB is also offered as part of the Azure Free account, which offers access to a wide variety of Azure products that you can use to build your apps for free, including things like Azure Functions, App Services, AKS, and many more. Let me show you how easy it is to enable free tier when you deploy your Azure Cosmos DB account. Here I am back in the portal. This time I'm going to add a new service to our resource group. I choose Azure Cosmos DB, click Create, choose my subscription and resource group, specify the account name I want to create, choose the API I want. Now if we scroll down a little, we have some options, one of which is the ability to apply free tier discount to the account we're creating. Just clicking this option on at the time of account creation will ensure that we get the 400 request units per second discount applied to the account. Remember, only one account per subscription can have the free tier discount applied. And then lastly, options to specify whether we want non-production use, geo-redundancy, and multi-region rights. All of these are disabled to ensure that we keep the costs of our development account down. Obviously, for production accounts, we would want to make these choices based on the needs of our application, as discussed earlier. The provision throughput offer we have covered so far lets you provision throughput capacity. But what if you don't need any real throughput? When, for example, performing development or testing activities, or even when running small, non-critical applications, our data may sit idle most of the time and only needs to process requests occasionally. We can certainly use autoscale here again, as it will dynamically scale up the delivered throughput whenever a request kicks in. But because the billing granularity of autoscale is 1 hour, and because it always provisions at least 10% of maximum throughput you've configured, this would represent unused capacity. To best accommodate this kind of workload, we're introducing a new offer, serverless. Azure Cosmos DB serverless is going to be a pure consumption model, where only request units consumed by each application request will get billed. This eliminates the need for the provision capacity concept and request units per second for this scenario altogether. We recently announced this new offer at Build 2020, and it will be available in public preview within the next couple of months. In this video, I hope to have provided you with some insight into what makes Azure Cosmos DB a great database for your cloud-native applications. We've also explored the provision throughput offer that is available today on Azure Cosmos DB, demonstrated how you can optimize your cost by appropriately selecting the options that's best for your workload, and finally introducing the new serverless offer that will become available soon. By giving you the granular control to handle any traffic pattern, these comprehensive offerings ensure that Azure Cosmos DB is a cost-effective solution for any workload.